60. Oh my God, me YouTube famous. All right, so we are graphing exponential functions. This is a big, huge, fat review from Algebra 2 for the most part. Plus, we've already done transformations and stuff this year with other parent functions, so we should be able to knock this out pretty quickly. All right, so let's talk about what an exponential function looks like. Parent function is basically going to be f of x equals b, excuse me, to the x power, where b is the base. But when we want to graph a parent function for that, we have to put in a number for b. Otherwise, we don't have anywhere to put things on the graph. So usually the parent function, like when you're trying to be generic, we'll use 2 and 1/2. But really it could be anything. It'd be f of x equals 5 to the x, and that's the parent function. Because this down here refers to a, go ahead and write one of the transformations in on here. We could have a times b to the x power. And when I have that, what does the a do? How does it affect the graph? Close. It's a stretch. What kind of stretch? Vertical stretch, because it's out in front, so it's a vertical stretch. All right, so when we have the b part here is greater than 1, then it's going to be exponential growth. When it's less than 1, it's exponential decay. So these graphs have something that not all the graphs do, and what would that something be? An asymptote. So how many asymptotes does an exponential have? 1. Is it horizontal or vertical? Horizontal. Okay, well let's see what happens, and we'll see if we can figure out this. So we've got when x is 0, if I'm going to graph this, so when x is 0, what's y? 1. Thank you. That's been giving me a headache all day. All right, when x is 1, what is y? 2. I know these are really hard questions. And then when x is negative 1, what's y? 1/2. Okay. So then we go back to this vertical or horizontal asymptote, and where is it? Is there anything that I can any real number I can substitute in for x to make the y value 0? No. Or negative. Like I can't make it 0 or negative, right? That's why we have an asymptote here at y equals 0. And then this is what your graph looks like. There's your exponential growth. So then when b is less than 1, that's our exponential decay. Well, when we're graphing this one here, when x is 0, what is y? 1. When x is 1, what is y? 1/2. When x is negative 1, what is y? 2. You don't know your basic exponent rules, I don't know what to tell you. And then asymptotes there, and my graph looks like this. Okay. All right, so there's your exponential growth and your exponential decay. How are those two graphs related to each other? They're reflections. A reflection in what? The y-axis. So when you reflect something in y, do you change the sign on x or on y? On x. So look at this. If I have f of x, well, yeah, let's just say I've got 2 to the x power. I don't know, what am I even trying to do here? Hang on. Sorry, my brain fart there. If I want to take 2 to the negative x power, is what I was trying to get out of my brain here, then that is the same as 2 to the negative 1 times x power, right? What's 2 to the negative 1 power? 1/2. So this is 1/2 to the x power, right? That's where that's coming from. And then the same thing can be said when I go the other way. If I do 1/2 to the negative x power, then that's the same as 1/2 to the negative 1 times x power. So 1/2 to the negative 1 power is 2, and I get 2 to the x. So technically, we really only have to talk about one of these, because I can represent this as 2 to the negative x power, basically. But that's usually how we talk about them, because you can see that a little bit better, but that's what's happening with your growth and decay. All right, so then let's talk about the natural base exponential function. So if we have f of x equals e to the x power, right? So you learned e when you were talking about what? Logs, okay? So you have log base 10, base 5, base 2, whatever. But then if you have a log base e, that's actually a natural log. That's why it's called a natural base exponential function. E is a number that you should know because that comes up in Algebra 2. It's a constant. It's not a variable, even though it's a letter, like pi. Pi is a constant because it's always 3.14159, blah, blah, blah. E is an irrational number, but we would much rather it be represented with E than with what it actually is. It's an irrational number with an approximate value of 2.71828. I never can remember the last two numbers there. But it's not the last two numbers. I shouldn't have said it like that. The last two I was going to write. It's definitely not the last two. We can't find the last two. But it looks like that. So exponential functions with base E are called natural-based exponential functions. Many real-world applications of exponential functions use base E. We'll talk a little bit more about what E is, where it comes from, why we use it in the next couple days. But right now, I know it's not new to you, so we're just going to talk about what it is. Here's what you have to know for the graphing part of this. Since e to the first power is about 2.718, I mean, that's it to 3 decimal places. But you don't even have to get that accurate on these graphs because it's so small, you don't know if you're that accurate or not. So as long as you know that e is about 2.7 to graph, you're good. Then you also need to know e to the negative 1 power, which is the same as 1 over e to the first power, right? And that is about 0.367879. Again, do we have to be that accurate on this graph? Absolutely not. As long as you know it's about 0.36, you are good. Okay? As clarification, you would never, ever substitute in 2.7 or 0.36 to solve a problem to get a value, like ever. If you're going to have to use it, you're using a calculator using the E button. Just like for pi, you would never in any real situation use 3.14. Like, no. I know they make you do that in junior high. It makes my skin crawl. Just no. Okay? So you would never do that. 22 over 7, oh my God, even worse. Like, no. Right? It's all about being exact, so you have to use the buttons where the calculator gives you the real number. This is just so we can estimate on the graph, because even if we had the exact number, it's not going to look any different on our graph. Okay? But these two numbers. Now, 2.7, you should really already know that E is about 2.7, so this should only be the new part. I'll tell you what goes on in my head, which doesn't make a whole lot of sense, I know. A lot of stuff in my head doesn't make a lot of sense. But there's no mathematical basis to this. But you know when you see one thing, it also kind of like makes you think of something else. So this is 2.7, but if you flip that around, that's 72, right? And half of 72 is 36. And so that's how I keep the number correct. Like, I know it's 2.7. And then if I'm thinking, is it 0.38 or was it 0.28 or whatever, like it's just like how the numbers are related. Not mathematically anything. But you also could just go up 1 here and down 1 there. That works too. I mean, whatever. Do you have a question? Oh, just because we truncate. You can truncate and it's fine. I mean, yeah, if you would round to 0.37, but it doesn't matter either way. And whether it's 0.36 or 0.37, is it going to matter on this graph? It's not. But you'll learn when you get into calculus, like we make you round all the way up through pre-cal, but really having numbers truncated or rounding, either one is kind of okay. But you're asked for rounding more often, so we have to make sure you can practice it. But yeah, 0.37 would be fine too. All right, so let's graph. So this is an exponential growth function, right? This parent function looks like this. It looks just like y equals 2 to the x power. Well, not just like, I mean, but the shape is the same. It's a f of x equals b to the x. B just happens to be e here. So when I'm at 0, what's my y value? 1. E to the 0 power is 1. Okay, a monkey to the 0 power is 1. It's like been the hardest question all day. It makes my head hurt. All right, so then when x is 1, y is about what? 2.7. 1, 2, 2.7, right? And then when x is negative 1, what's y about? 0.36? See, whether it's 0.36 or 0.37 or 0.367879, I don't think my point's going to move. It's probably not even that accurate anyway. Then my asymptote is still the same here. And we graph that in like so. Okay? So is this exponential growth or decay? Growth. And the domain, negative infinity to infinity. What's your range? 0 to infinity. Do I include 0? No. Do I know my y-intercept here? Oh, Lord, I hope so. 0, 1. Okay, my asymptote is y equals 0. Is this increasing or decreasing? Increasing. And it's going to be one or the other here. You're not going to have it parts and parts. So it's increasing from negative infinity to infinity, and it's decreasing none. In behavior, as x approaches infinity, f of x approaches infinity. And as x approaches negative infinity, f of x approaches 0. Okay, so it came up a few times with rationals that we're skipping in behavior. Like, why are we skipping this? But I said we're not. It said in behavior, and then we had horizontal and slant asymptotes. Well, we have a horizontal asymptote here, but we're actually writing it down this way. It's because it means different things. And with a rational function, if in behavior-wise I say, oh, I have an asymptote, it's y equals 0. For a rational, if I have an asymptote that's y equals 0, then that means at positive infinity and at negative infinity, I am reaching 0, like on both ends. I don't need to write it out like this. But here, even though I have this asymptote, two different things are going to happen because this isn't a rational. It gets treated differently. Okay. So here, as x approaches infinity, we go to infinity, and it goes to 0 the other way. Okay. That's why you have to split it up a little bit. All right. What questions do you have right now? Okay. So good question. Do we have to check if it crosses the asymptote? Is this one ever going to be able to? No, because of the nature of the function, so I won't have to. Since I can't, there's nothing I can substitute in for x that's going to give me a y value of 0 or a negative one, so you won't ever have to check on these. It's a very good question. What else you got? Anything else? All right, flip it over. Because on the rationals, we can cross them. Here, even though, like, you can cross a horizontal asymptote. Not every function can, though. For these, you can't. Like this. For an exponent, if it's truly an exponential function, you cannot cross the asymptote. That's why the asymptote's there. It's just a different type of function. Does that make sense? Okay. All right. Yeah. All right. So transformations. So here's like a little review, quick review of transformations. I deliberately use different letters here because you could see it either way. And you actually may have used H and K in Algebra 2. It depends on who your teacher was. Whether you will use H and K here or C and D, it depends on who you talk to, what class you're in, who's your teacher, what book do you look at, who you want to argue with. Like, it doesn't really even matter. As long as you know that x plus something is going to shift it to the left and x minus something is going to shift it to the right, that's all that really matters. So whether it's H or K or C or D or whatever, it's still the same process. So I just wanted you to know that it's the same either way. Okay, so let's identify. The first thing we have to do is identify the parent function. Okay, so our parent function, it is an exponential, so it'll be f of x. Basically, I'm looking for my f of x equals b to the x. I got to fill in that b. What is the base of this exponential function here? 4. 4 to the x power. The base is whatever the bottom part is of the x thing, right? Y'all know that. So then this, it means it's exponential growth, so it's going to look like this. Once I've identified that, then the b part says to describe the transformations. All right, so I'm going to start with that negative here. The negative, I know, means I'm going to have a reflection, and this is going to be a reflection in what? The x-axis. Good, because it's not touching x, it's affecting y, so it's a reflection in the x-axis. Then I move on to the 3. The 3 is going to do what? Vertical stretch. Good. Vertical stretch by a factor of 3. The 4 is not a transformation. The 4 is part of the parent function. So then I move to that exponent. I got x minus 2. What does the 2 do? To the right 2, because it's with the x. Good. And then the 7? Down 7. It's way easier to see if things affect x or y in these, because if it's affecting x, it's got to be in the exponent. It's the only one that's going to work. Okay, we all good so far? All right, let's look at number 2. Because nothing's being multiplied by x. Does that make sense? Okay. Are you just stretching? Okay. All right, so then my parent function here, f of x equals what? E to the x power. So the same basic shape is going to happen, exponential growth. All right, so then my transformations, what does that 4/3 do? Vertical stretch. Good. It is a fraction, but it's greater than 1, so it's a vertical stretch by 4/3. Then e is part of the parent function, so I don't do anything with that. I've got a negative x, so that negative is going to be a reflection in what? Good. in the y-axis. And then the 5 is going to do what? Up 5. All right, what questions do you have? If the base is greater than 1, it's a growth. If it's decay, like if it was 1/4 instead of 4, then it would be decay. Like it'll never be negative. The negative always means something else, but yeah, so if it's less than 1. We good? All right, let's look at number 3. A, we'll get f of x is equal to e to the x power. So this is exponential growth again. B, we start to look at the transformations. That negative is going to be a reflection in what? Good. Reflection in the x-axis. Then the e is part of the function. That 1/2 is going to be a what? Good. A horizontal what? Stretch. X lies. It's a horizontal stretch by 2. X lies. Then the 4, I do what? Up 4. Good. Translate up 4. Yes, ma'am. The negative is just the reflection. The base itself is just e. The base is e on both of these. You see that? And then this negative is that reflection right here. Does that make sense? Okay. Anything else? That's a good question. Yes. It does. What's the only thing that's going to affect the asymptote? The y value. Yeah, but the shift, right? If the function gets shifted up or down, then the asymptote's going to get shifted up or down. Yes. Very good question. All right, so let's look at number 4. What's the base here in number 4? Good, 3/4. F of x equals 3/4 to the x power. Now, this has to be in parentheses, because if not, it's going to look like 3 to the x divided by 4, and that's not what we want, right? So if your base is a fraction, it's got to be in parentheses. So is this exponential growth or decay? Decay, because that's less than 1, so it's going to look like that. So then we look at our transformations. That negative means we're going to reflect it in what? X-axis. The 3/4 is part of the function, right? That 3 in the exponent is what? Horizontal compression. Good. By 1/3. Right, because x lies. And then the 2 is what? Left 2, and the 1? Down 1. What questions do you have? Nathan asked me a question. I can tell by the look on your face. What happened with the 3/4? That's the base. You got it? Okay. Any other questions? All right, so if we can do this, we can graph them. So let's grab that other piece of paper and let's graph. This is going on 61. We're going to start with a really easy one. So the first thing we're going to do every single time is identify the parent function. F of x equals 3 to the x. That is exponential growth. Then we draw our little thing right here. And I know that most of you think that that is a complete waste of time and it's stupid. Okay? But let me tell you, once we start graphing trig stuff that you've never seen before, if you're not doing this and you can't refer back to that parent function to figure things out, you're not going to have a clue what you're doing. So you need to get in the habit of doing it every single time. Okay? That way it's just not even a question about whether or not it needs to happen. All right, so then I'm going to look at my transformations. 3 is part of the function, so that 1 does what? Right, 1. And the 4 does down 4. Okay, so I think that the best thing for you to do is the first thing that you graph is your asymptote, because it's the easiest thing to do. You won't forget to do it if you do it first. And sometimes it helps you realize that something's not right in the end when it's just something's weird. So the only thing that affects the asymptote are your vertical shifts up and down, right? So this goes down 4. So instead of being at y equals 0, we're going to be at 1, 2, 3, 4, at negative 4. Right there. And then I can go ahead over here. My asymptote is at y equals negative 4. I already got that part done. Then I'm going to start graphing exactly like I did every other parent function. I start with the parent function part. So for the parent function of 3 to the x, When x is 0, y is 1. So then from that point, I'm going to go to the right one, and I go down 1, 2, 3, 4. Boom, there's my point. For the parent function, when x is 1, what is y? For the parent function, this is my parent function. Yeah, 3. When x is 1, y is 3. Like, that's where I have to start. And then from there, I do my transformations. I go to the right one and down 1, 2, 3, 4. So then for my parent function, when x is -1, y is 1/3. Then I move to the right one, and I go down 1, 2, 3, 4. So there are my 3 points that I need. And they're the only 3 points you need. Somebody asked me that earlier. And that's it. That's fine. Then it just goes up or goes to the side or whatever. All right, so then my domain. Domain is -infinity to infinity. My range is -4 to infinity. Do I include -4? No. Do I know my y-intercept? Yeah, I graphed it, right? There's a couple different ways to come up with it. Yes, I can find f of 0. I can reason through where I started. Like I started up here with the y value of 1/3, and then I had to go down 4. So I'm 1/3 away from that -4. You can figure it out that way. Or I go 1, 2, 3, and everything but 1/3. So that's -3 2/3, right? I'd even be okay with a mixed number in this. The whole idea of just like trashing mixed numbers is, first of all, you hardly ever want to actually use them for anything, but you also don't want to do more work. So if you end up with something, you have an improper fraction, leave it. Don't make it into a mixed number. But if it's easier to say, okay, I understand that this is 1, 2, 3 2/3, then you're at 0, -3 2/3, and that's fine. Okay, if you make it into an improper fraction, that's fine too. Just not really necessary here. All right, is this increasing or decreasing? Increasing. -infinity to infinity. So this is none. As x approaches infinity, f of x approaches infinity. As x approaches -infinity, f of x approaches -4. Okay, everybody good with that? Yes, ma'am. Because it's the asymptote, right? Because you're not actually going to have a y value of -4 ever. What else you got? Any other questions? All right, let's jump down to number 3. So my parent function, f of x, is equal to 1/4 to the x power. This is exponential decay. All right. So then I look at my transformations. That 3 is going to be a vertical stretch by 3. The 1/4 is part of the function. The 5 does what? Left 5. Okay. All right, so then does the asymptote move off of the axis? No, I do not have a shift up or down, so it is still here at y equals 0. Y equals 0. All right, so I start with my parent function, 0, 1. Then I do my transformations. Vertical stretch by 3, so I multiply 1 by 3 and I get 3. And then I move to the left 5. 1, 2, 3, 4, 5. Then when x is 1, y is 1/4 for my parent function. I have a vertical stretch by 3. Well, 1/4 times 3 is what? 3/4. So I don't go very far. And then go to the left. 1, 2, 3, 4, 5. When x is -1 in the parent function, y is 4. Vertical stretch by 3 gives me 12, so it goes off the graph too, but we'll still use it. And then we move to the left, 1, 2, 3, 4, 5. If it goes off the graph by like 1 or 2, I would say still use it because it can be helpful. If it's all like way off, then it's way off, and we don't worry about it. And then I can sketch this in. Like so. And just as a little side note here, just because this is exponential decay for my parent function doesn't mean that my actual graph has the exact same shape. Because if I had reflections or something, it could look different. But that's where I'm starting from. All right, so my domain, once again, -infinity to infinity. If you haven't figured it out yet, for all the exponentials, that's what it's going to be. Your range is from 0 to infinity. Do you know the y-intercept? No, but do you have one? Yes, clearly I do. So we have to go find it. So we're going to find f of 0. That's equal to 3 times 1/4 to the 5th power. Now, we want to work smarter, not harder, right? And so 1/4 to the 5th power, if I knew what 4 to the 5th power is, I'd be golden, all right? But probably don't just know that. I would not just take 4 times 4 times 4 times 4 times 4. Like, I would not do that myself. I'm not saying it's wrong. I wouldn't do it that way because that's a lot of work. Instead, I would think about this differently. So I'm not saying this is the only way or it's the best way. It's just what works best in my mind. Isn't this the same as 4 squared times 4 squared times 4 to the 1st? Is it the same thing, right? So 4 squared is 16. So this gives me 16 times 16 times 4. Right? What's 16 squared? 256. Okay? So I have to do 256 times 4. Anytime I multiply by 4, if I don't just know what it is, then I double it and double it again. So I would take 256 and double it. What would I get? 250 doubled is 500. 6 doubled is 12, so it's 512. Then I'm going to have to double that, and that gives me 1024. Again, one way to do it, just one way to use some number sense to split it up. If I was actually working this problem on my own, I wouldn't write all that stuff down. I wouldn't necessarily expect you always to write all that stuff down. I'm also not saying you absolutely have to do it in your head. Yes, sir. Oh, that's fine too. If you know, do you just know what that is? Oh, I don't think so, because I think the more powers you have, the worse off, because you're just going to have more to multiply. So, like, yes, you could do that. Like, it would be fine. It would be legal. But unless you just, like, knew what that was for some reason or you could do that, I just wouldn't suggest that. That not me personally. But there's nothing wrong with it. Yes, sir? Is that always legal to, like, divide the number and then double the number? It's not dividing it. It's because, you mean legal what he said? Yeah, well, like, okay. So, well, what he said was if I have 4 to the 5th, that is the same as 2 squared to the 5th power, right? And so that makes it 2 to the 10th, and it would have the same value. It has to do with the power, not like dividing. 4 is just one of those numbers where, 2 plus 2 is 4, 2 times 2 is 4, 2 squared is 4, like all the same things. But if I was doing this on my own, this kind of stuff would just be a thought process in my head, like up to there. That would just be like, okay, I can split it up like this, and then I wouldn't do the rest in my head for sure, because I would lose those numbers somewhere in my brain. I would say, okay, if I'm thinking I got to do 256 times 4, so I have 256, but then I'm going to have to double that. That gives me 512. Double that, it gives me 1024. So like this is probably the extent of what my work looks like, which would make sense to nobody looking at my paper, but it doesn't matter because that's like your scratch work. You with me on that? I'm just trying to help some of you minimize the insane stuff you have everywhere. But again, if that's because that's where mistakes happen, and it also is taking up way too much time. Practice this stuff, you'll get better at it. But yeah, again, not the only, because somebody else said, oh, well, if I did this, if I had 4 quarters, well, absolutely. There's other ways to do it, and I'm not saying it's the only way. It's just the way I think that everybody could understand, even if it's not your favorite, right? But now 1024 is not my answer. I've got to be able to use it correctly as well. This is going to be 3 times 1 over 1024. Which means my y-intercept is 0, 3 over 1024. Now, does that seem like a reasonable answer? Yes. Does my graph look like maybe it's off by a little bit? Yeah. Am I going to fix it? No. Okay. I mean, I could, but my problem here really is that I kind of missed that point. I think if I'd hit that point better, I'd be closer to the axis, and I was in some other class periods, but it makes sense. I should be really close to the axis at that point. All right, so I'm not increasing anywhere. I'm decreasing from negative infinity to infinity. And then this would be 0. This would be infinity. Do we agree with all that? Yes, yes. All right, flip it over and let's do E. All right, so first thing I do, parent function. F of x equals e to the x. That is exponential growth. Then I look at my transformations. That negative means we're going to have a reflection in what? Y-axis. Good. And then the 3 means we do what? Up 3. Okay, so does my asymptote move off the axis? Yes, it does. It goes up 3. So I'm right there. And then my asymptote is at y equals 3. So then I go to my parent function. I start at 0, 1. I reflect it in the y-axis. Well, if I'm on the y-axis, I'm not going anywhere. And then I go up 1, 2, 3. I end up right there. Which also means that I know my y-intercept, it's at 0, 4. All right, so then for my parent function, when x is 1, y is about what? 2.7. So I start up here at 2.7. I reflect in the y-axis, which means it goes over here. And then I go up 1, 2, 3, and I'm about right there. For my parent function, when x is negative 1, y is about 0.36. I reflect in the y-axis and then move up 1, 2, 3, and I'm about right there. And E is not any harder than any of the rest. You just have to know the 2.7 and the 3.6. All right, domain, negative infinity to infinity. Range, 3 to infinity. Is it increasing or decreasing? Decreasing, so this is none, and this is negative infinity to infinity. As x approaches infinity, f of x approaches 3. And as we approach negative infinity, f of x approaches infinity. All right, what questions do you have? All right, one more together, and then I'll... Parent function, f of x equals 1/3 to the x power. That is exponential decay. That negative means I'm going to have a reflection. This would be a reflection in what? X-axis. The 1/3 is part of the function. The 2 is going to be a horizontal compression by 1/2. And then that 1 means I do what? Go to the right one. Everybody okay with all that? Does my asymptote go off of the axis? No. So it's right here at y equals 0. There we go. Y equals 0. Oh, that is not my y-intercept. Oh, hang on. Put it in the wrong spot. Y equals 0. So then I start with my parent function. For the parent function, I'm at 0, 1. I reflect in the x-axis, so I come down here. Horizontal compression means I multiply the x value by 1/2, so that's still at 0, and then I move to the right one. Then, from the parent function, when x is 1, y is 1/3, I reflect in the x-axis, it comes down here. Horizontal compression by 1/2, my x value is 1, so I multiply by 1/2, I'm at 1/2, and then I move to the right one. And it ends up right about there. When x is negative 1, y is 3, right? So I reflect in the x-axis and I end up down here. Horizontal compression by 1/2 and move to the right one. All right, so before I draw this in, the other ones where I've had y-intercepts, that they've been in between some of those points, so when I sketch it in, I'm pretty much going to hit it anyway, as long as I'm kind of accurate. But here, if the y-intercept is something I can graph, then I want it on there so I know where to hit it. And then maybe it's way off the graph and I don't even get to graph it, like we'll just see. So I need to find it first. So we'll find f of 0. That's equal to negative 1/3 to the 2 times negative 1 power, right? So 2 times negative 1 is negative 2. So 1/3 to the negative 2 power is what? Okay, so the negative is going to flip it, make it 3. Yeah, negative 9. So we just get negative 9. So your y-intercept is 0, negative 9, and that is something that's on my graph right here. So I need that on there so I can hit it when I'm trying to sketch this in, or hopefully hit it. Let's see. Like so. There we go. Domain, negative infinity to infinity. Range, negative infinity to 0. I already have my y-intercept and my asymptote. Is this increasing or decreasing? Increasing. Negative infinity to infinity. This is none. This is 0, and then negative infinity. Okay. What questions do you have? All right, so I want you to work on number 6 on your own while I hand out the assignment. After I hand it out, then I'm going to work on it quietly on my own so that you can get it done, but then we can talk about it. So don't be just copying my stuff down. There. See if you agree with everything I have so far. What am I missing? Y-intercept. And I have one, right? So I got to find, but I can't guess off the graph. So f of 0 equals e to the 1/3 times 2 power minus 1, right? So what's 2 times 1/3? 2/3. So I get e to the 2/3 minus 1. Do you think I want you to take 2.7 to the 2/3 power? No, I do not. Because remember, we don't substitute in 2 points. That was just to get some estimations on our graph. If you did something crazy, or you did something and you got a crazy number for a y-intercept, like the square root of 17 plus 5, what would I expect you to write over there? Square root of 17 plus 5, right? Do you have any concept of what this value is? No. You don't have any concept of that value either, but this is it. That's your y value. It is 0 e to the 2/3 minus 1. So if I actually needed that value, I would type it in the calculator, but we need to find this. Like, this is my exact answer. We're all about exact answers. But given this and given our graph, can you give me maybe kind of an estimation or tell me something about the value? One-ish? Yeah, it's one-ish. So one-ish is a good way. It's a little less than 1 based on like my graph, but that's why I regraphed it because I missed the point again, so it's like way off. But it comes out when you actually do type it into a calculator, which you would not have to do, by the way. Just telling you that this becomes about 0.9477, so it is just a little bit less than 1, which is what your graph represents, right? So if you had a multiple choice or you had something to guess, like something pretty close to 1 makes sense for that, okay? What questions do you have? Anything? You still use -1, 0, and 1. I did the exact same thing. You go with the parent function. For the parent function, when x is 0, y is 1. So I was here at 1. At a horizontal stretch by 3, I moved to the left 2 and down 1. So then when x is 1, y is about 2.7. That's coming from my parent function right here. I start at 1, 2.7, because e to the first power will be 2.7. Then I do a horizontal stretch by 3, so I multiply my x value by 3. I end up right here. Then I move to the left 2 and down 1. It's the exact same process. Those points all come from the parent function. You just have to ask yourself, when x is 1, what's y? That's from the parent function question. Okay, does that help? Yes? What other questions you got? All right, good deal.